Okay, so let us discuss what do we mean by LCR circuits and how to solve questions of LCR circuits. Okay, so what is an LCR circuit? Suppose we have inductor, capacitor and resistor all connected to an alternating voltage, all connected to an alternating voltage V, all connected to an alternating voltage V, that is V equal to V naught sine omega t. Suppose inductance is L, capacitance is C, and resistance is R. Now we know one thing, that for resistor, for resistor, current and voltage are in phase with each other. For resistor, current and voltage are in phase with each other. So current and voltage are in phase. For inductor, we know that voltage is ahead of current. And for capacitor, we know that for capacitor, current is ahead of voltage. So please remember this thing, that for resistor, the direction, or we can say that there is no phase difference between current and voltage. For inductor, voltage is ahead of current. For capacitor, current is ahead of voltage. So since all three are in series, so current will be same in all. Since all three are in series, so current will be same in the all. So let's draw the phasor diagram. So what is a phasor diagram? The phasor diagram will represent the current and voltage. Let us understand how. Let us understand how. Suppose I draw, suppose this is a phasor diagram. Since we know that current in all will be same, suppose this arrow represents current. Suppose this arrow represents current. So for resistor, we know that current and voltage, are in phase with each other. Suppose this is current. Suppose this is current. So voltage across resistor will also be in the same direction. Because for a resistor, current and voltage are in phase with each other. So this arrow represents current. So this is our current, and for resistor, current and voltage are in same direction. So voltage across resistor will be in same direction. But remember, for a capacitor, current is ahead and voltage is behind. So this will be the voltage for capacitor, because current is ahead by voltage by pi by 2. So this will be pi by 2. So this is voltage of capacitor. This is current, because current is ahead. The one will be ahead, will be in anti-clockwise direction, will be in forward in anti-clockwise direction. So this is voltage of capacitor, this is current, and you can see the current is ahead of voltage for capacitor. And for inductor, the voltage is ahead. So for inductor, voltage is ahead and current is behind. So this is current. So for inductor, voltage will be in this direction, that is VC. So VC, so voltage across inductor is ahead of current. Current is ahead of voltage for capacitor, and for resistor, both are in phase with each other. So what we have is, we have VR in this direction, that is parallel to the current, VC in this direction, sorry, VL in this direction, and VC in this direction. So this is voltage across capacitor, this is voltage across inductor, and this is voltage across resistor. Now we'll simplify this diagram more. So you can see VL and VC are opposite. Suppose VC is greater than VR. So the final diagram will be VR, and this will be equal to VC minus VL. And suppose the net voltage is, V. So we'll again simplify this diagram. So we have VR in this direction, and in this direction we have VC minus VL, and this will be the net voltage, and this will be the RMS voltage applied, and the value of V will be given by VR square plus VC minus VL whole square. And this V is VRMS, that is V naught by root 2, where VR is RMS voltage, RMS voltage across resistor. Similarly, VL is RMS voltage across inductor, and VC is RMS voltage across capacitor. So this is the RMS voltage. V naught is the voltage, maximum voltage of the source. V naught is the RMS voltage of the source. So VRMS will be V naught by root 2, and this will be our formula. Now let us find out the impedance of circuit. So what is impedance? Impedance is basically overall resistance or reactance of LCR circuit. So let us find out how. So we have V equal to root of VR square plus VC minus VL whole square. Now we know that voltage across resistor will be IR, where I is RMS current. Voltage across capacitor will be IXC. Voltage across inductor will be IXL. Now putting all the values in this equation, so V will be, the I will come out, it will be root of R square plus XC minus XL whole square. And this thing will call Z. And Z is basically impedance of circuit whose SI unit will be ohm. So Z will be root of R square plus XC minus XL whole square. Now in the case of LCR circuit, it is not necessary that current and voltage will be in phase or they will be ahead by pi by 2. So there will be a phase difference between current and voltage. Now how to find out that phase voltage? So we know that this is voltage across resistor, and this is VC minus VL, and this is our voltage V. So this is our voltage V, this is VC minus VL, and this is voltage across resistor. We know that current is in this direction. We know that current is in this direction, and this angle is phi because current and voltage across resistor are in same direction. And this is our net voltage. So this is our phase difference phi. So now if you'll see, then tan phi will be equal to perpendicular, that is VC minus VL, and base this is VR. Now putting value of VC, that is IXC, VL, that is IXL, and VR, that is IR. So tan phi will be XC minus XL divided by R. So this is how you have to calculate phase difference between current and voltage. So tan phi will be XC minus XL divided by R. So this is how you have to calculate the phase difference. Remember, if XC is greater than XL, then the circuit is capacitive is in nature and current will be ahead of voltage by phi. And if XL is greater than XC, then the circuit will be inductive in nature and current will be ahead of voltage by phi. So this is how you have to calculate phase difference, you have to calculate impedance. Okay.